All right, here's 3.1, I guess 3.1B. We're going to talk about we're still talking about the rectangular coordinate system. We've talked about this in 3.1A. So the rectangular coordinate system, we kind of went through a little bit of information about comparing and contrasting whether we can find information better from a table or from a graph. Some questions lend themselves to a table, some questions lend themselves to a graph. So let's talk about the rectangular coordinate system, kind of how it's set up. We're going to go back to kind of chapter 1, I guess, and we're going to talk about a line, and we're going to talk about the rectangular coordinate system itself being a graph with two number lines, essentially perpendicular to each other. And I guess we start with the x-axis. So the x-axis, we're going to talk about the x-axis as a number line. So the number line, remember the number line is just a number line. And it has a 0. It has, and I'll put an x over here because that's our x-axis. It has positive numbers to the right, it has negative numbers to the left, and that's our x-axis. So if we're talking about our rectangular coordinate system, x-axis is the horizontal axis, just like the horizon. If you're looking out of the horizon, that's what the horizontal axis is. If we talk about the y-axis, and that flashing stuff just comes from when I change pen colors. Anyway, the y-axis is going to be the number line, the exact same number line with some numbers positive on the right, some numbers positive on the left, but we're going to essentially take that number line and just turn it to the a perpendicular way. So now our number line for the y-axis is again just a number line. And there's our number line. Our positive numbers are going to be up here for the y-axis. Our negative numbers are going to be down here for the y-axis. And that's going to be the y-axis is going to be our vertical number line, essentially in just a number line. Here's our 0 point right there. Where they meet is going to be at 0 on the y-axis, 0 on the x-axis, and that's going to be something that's called the origin. So the origin is right there. Origin. Right there, where y is 0, not positive, not negative. X is 0, not positive, not negative. It's just going to be 0. Where those two number lines meet, that's going to be our origin. So that kind of leads us to the idea that we have 4 different, let's say, quadrants. So a quadrant means it's 1/4 of our area. So if we talk about quadrants, quadrant number 1 is there, quadrant number 2 is there, quadrant number 3 is there, and they do go by Roman numerals. Quadrant number 4 is there. So we start here, quadrant 1, quadrant 2, quadrant 3, quadrant 4, and those are just the quadrants. Quadrants means 1/4 of our area here, or our rectangular coordinate system. This usually goes back to 1, 2, 3, and 4, like set up like this, kind of in a counterclockwise position like this. Goes to more trigonometry, I believe. I kind of did some research and really couldn't find out exactly why that was set up this way with quadrant 1, quadrant 2, and 3, and 4 set up that way. But I think when you get into trigonometry, you talk about a unit circle and measuring degrees from this is your 0, and then going back this way to 90 degrees and 180 degrees and 270 degrees and 360 degrees, and that's how it's set up that way. Again, just a kind of a standard that was just set some way. So those are our quadrants. Keep in mind that the number lines are not on any quadrants. So the green y-axis, the blue x-axis are not in any quadrants. The quadrants are just the open spaces that don't have the x-axis or the y-axis in it. So because we've set up our x-axis and our y-axis, we can say that, well, now we've got an ordered pair. We're going to have, or we're going to be able to have ordered pairs of information. An ordered pair is just basically information that's used to plot a point. You can say that, well, if I've got a point here, then that point corresponds exactly to an ordered pair. That is my x-axis or x point, and that is my y point that corresponds with that point that's in our quadrant, or in our rectangular coordinate system. So for any specific point here, we're going to have an x-coordinate and a y-coordinate, and that x-coordinate, y-coordinate is going to correspond exactly to that one point. And the same holds true for the reverse. If we've got a point, then that x-axis and that, the x point and that y point corresponds exactly to that y, or that point itself. So keep in mind that if we have an ordered pair, the ordered pair looks like this. Usually it has a bracket. Left bracket, right bracket, here's our x point, here's our y point. So if we've got a value here for x, let's say that's 1, well then the x value for that point here would correspond to the 1 down here. If 1 is here, then that corresponds to that point, and that 1 goes down here. The y value would be, let's say that would be 2. Our scales are not necessarily exactly the same. So if that y point is 2, then that y value comes down here for an ordered pair, and that's exactly what an ordered pair would look like. 1, 2 would correspond to 1 in the x direction and 2 in the y direction. And correspondingly, I guess if we had also a, let's see, something that would be maybe over here, this point would be maybe -2, because again, in our x coordinates, or x-axis, positive would be over here. We'd have to measure negative direction from our origin this way to get our -2 value for our x. So this point would be -2 in the x direction, and 1, +2, because it's still in line with this 2 here, +2 in the y direction. So this point, -2, 2, tells us to go from the origin -2 on the x direction, and then +2 on the y direction. And that would be that point right there, -2, 2. So with that in mind, again, we've got to measure our, or I guess talk about plotting points in a rectangular coordinate system. So let's do plotting points, and the next page, getting points from a plot, in the next video.